Welcome to EDU World Space.
So in this video, we're going to talk about question 34 from chapter 20, which says elemental boron is produced by reduction of boron oxide with magnesium to give boron and magnesium oxide. Write a balanced equation for this reaction. So our reactants are boron oxide and magnesium. So let's start out by writing those out. So first we need to figure out what the formula is for boron oxide. So we know that oxygen tends to react to gain 2 electrons in order to have the more stable noble gas configuration. So when it's acting as the anion in an ionic compound like this, it's going to take a -2 charge. And boron has 3 valence electrons, 3 valence S and P electrons. So it tends to react to lose those 3 electrons in order to have the more stable noble gas configuration. So it's going to have a +3 charge. So our cation has a +3 charge and our anion has a -2 charge. The least common multiple of 3 and 2 is 6. So we're going to need 3 of our -2 charges, and we're going to need 2 of our +3 charges in order to have this electrically neutral. So the formula for boron oxide is B2O3. And then we're reacting that with magnesium. And our products are boron and magnesium oxide. So what's the formula for magnesium oxide? Well, we know that oxygen likes to have its -2 charge, and magnesium is one of the alkaline earth metals in the second column or group of the periodic table. So it's going to take a +2 charge. It's going to give up 2 electrons to have the more stable noble gas configuration. So we have +2 and -2, so this is already electrically neutral. So the formula for magnesium oxide is just MgO. But this equation is not balanced. So on the left-hand side of the equation, for starters, we have 2 boron atoms, while on the right-hand side, we have only 1 boron atom. So we need to add a coefficient of 2 in front of boron in our products. And then another difference is that we have 3 oxygen atoms on the left, but just 1 oxygen atom on the right. So we need a coefficient of 3 in front of our magnesium oxide in order to balance our oxygen atoms. And then that gives us 3 magnesiums on the right and just 1 magnesium on the left. So we need another coefficient of 3 in front of magnesium in our reactants. So our balanced chemical equation ends up being B2O3 plus 3Mg yields 2B plus 3MgO.